Hello everybody, welcome to another video on the channel. In today's video we are going to talk about dynamically allocated pointers. And some people know them as pointers that are constructed using the new operator and deleted using the delete operator. So, as always, before we get started, please, if you enjoyed the video, you learned a thing or two, please drop a like. I would greatly appreciate it. And subscribe to the channel. And if you have any suggestions or you would like me to make a video on a certain topic, please drop it in the comments. Okay, so before we get started, let's talk about what is a dynamically allocated pointer. So the difference between a dynamically allocated pointer is that the memory is allocated on the heap versus when you just create a variable the memory is allocated on the stack. So for example, when you create a variable like this, the memory is allocated on the stack. Now let's talk about the how to allocate memory dynamically. So you do that using the new operator. So let's say we want to make an int pointer and we are calling it a pointer and we use it using the int operator and simply the type of the data type. So what does this mean? This means that we just dynamically allocated in the memory space for one pointer, right? So let's say we want to dynamically allocate, we want to allocate more than one space in the memory. How do we do that? We simply do that by doing this. And let's say we want 10. Now, what did we do? We made this pointer to, we allocated spaces for 10 integers, and this pointer is pointing to the first index of those 10 integer spaces that we just allocated. And as we know, the integer is 4 bytes, so 10 times 4 is 40 bytes, and that is the space allocated in the memory. So when we use a dynamically allocated pointer, it is extremely important to delete it after we finish using it. Now, what do we mean by that? And that is when the delete operator comes into action. You release the memory that the pointer is pointing to. And it is extremely important that when you allocate the pointer yourself, you have to release the memory because if you don't, you will get memory leak in your application and that is very bad. And when the pointer is pointing to more than one integer, when you allocate more than one integer space to it, you delete it by doing this, right? That's how you do it because you are deleting all the spaces that you allocated to it. Now, there is something that we like using, and that is this. So let's create a third pointer, and let's do new int std no throw and int. Okay, so what does this mean? What this means is that in the case that you are trying to allocate memory for this pointer, and in the case that there isn't enough memory to be allocated, the program does not throw. And how can you go ahead and use this pointer? You use this by simply saying if, for example, the pointer 3, because this will convert it to false. That means if there was not enough space to be allocated, you can go ahead and just comment something like, oh, error, log something like this, not enough space to be allocated. and go ahead and return, right? And then if it's not, if there was, else you can go ahead and do your work and simply make this pointer point to, let's say we have an integer variable equal to 10, and we simply point it to the memory address of this variable. And after you finish, you need to delete this, release the memory that is that this pointer is pointing at. So just to go ahead and conclude what we talked about is that when you want to dynamically allocate memory, you do that by using the new operator, and then once you're done with it, you've released the memory that you are pointing at using the delete operator. If you allocated more than one space in the memory, you need to go ahead and do that by release the memory by using the brackets, open close brackets. You can use no throw. I really like using no throw because, as I said, if there isn't enough space to be allocated in the on the heap, it does not throw, and then you can go ahead and double check and do your verification here. And when you allocate memory for a pointer, um, think of it as an array, and then the pointer is going to point to the first index in that array. So, as usual, if you enjoyed this video, please drop a like, subscribe to the channel, and hopefully in future videos I'm going to make a video on how to detect memory leaks if they happen, what are some common cases that memory leaks happen in, and also I'm going to make a playlist about references and other concepts in C++. So, see you later.